Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about centroids of areas, and it's a continuation of a previous video. In the previous video we defined what the centroid of an area was, and we looked at how to find the x-coordinate and the y-coordinate of a centroid of an area. We looked at using vertical rectangles, and I'm going to do another example just to review that concept. In the formula for both the x-coordinate and the y-coordinate, we needed the area of the region. So let's start there and calculate the area of a region bounded by y equals square root of x equals 4, and the x-axis. So we're going to take a look at this region right here, and we're going to find the area using vertical rectangles. So the area will be the integral from 0 to 4 of the top curve, which is square root of x, minus the bottom curve, which is y equals 0, dx. I'm going to write that as x to the 1/2, and then I can integrate it. It will be x to the 3/2. 1 divided by 3/2 will be 2/3. Then I'm going to evaluate it when x is 4. When x is 0, it's 0. So if the square root of 4 is 2, 2 cubed is 8. 8 times 2 is 16 over 3. So the area of this region is 16 over 3. Now we're going to find the x-coordinate and then the y-coordinate of the centroid. In order to find the x-coordinate of the centroid, we take 1 over a, so 1 over the area, which is 16 over 3, times the integral from 0 to 4 of the perpendicular distance to the y-axis, which would be x, times f of x minus g of x, that's the height of that rectangle, and it's going to be square root of x minus 0, which is just square root of x. The width of the rectangle is dx. So that will be 3/16 times the integral of x times x to the 1/2 will be x to the 3/2. So that will be 3/16 times the integral of x to the 3/2 will be 2/5 x to the 5/2. And now we evaluate. Let's just cancel a 2 there. So that's going to be 3 over 40 times 4 to the 5/2. Square root of 4 is 2. 2 to the 5th is 32. So we can cancel an 8 into there, an 8 into there. So 12 over 5 will be the x-coordinate of that centroid. Let's find the y-coordinate. So the formula for finding the y-coordinate is given. We're going to plug in area of 16 over 3. Integral from 0 to 4. Our top curve f of x is square root of x, so square root of x squared, minus the bottom curve, which is 0, squared is 0, dx. 1 over this will be 3 over 32. Simplify the integral. That'll just be an x. And now we can evaluate it. So that will be 1/2 x squared. So that will be 3 over 64 times 4 squared. Goes into there 4 times, 16 into there once. So the y-coordinate of the centroid will be 3/4. So the point that has that x and that y-coordinate would be the centroid of this area. If you can use vertical rectangles, then you want to proceed and follow this method. But sometimes it's going to be easier or absolutely necessary to work with horizontal rectangles. So let's take a look at how we would calculate the coordinates of the centroid using horizontal rectangles. So if we were asked to find the centroid of the area bounded by f of y and g of y from y equals c to y equals d, again, we're going to use the definition of a centroid. We're going to sum up all of those first moments, and those first moments can be calculated by finding the perpendicular distance from that rectangle or that sliver to whichever axes we're working with times the area of that sliver. And we sum them all up by integration. It's going to be easier to start with the y-coordinate because it's easy to define the distance of this rectangle to the x-axis because it's just a y and we're doing everything in terms of y. So the y-coordinate will be the sum, which is integration from c to d of y times the area of this rectangle, and this area can be described as f of y minus g of y. Times dy. That's the sum of all those first moments. We divide that by the total area. So we can simplify this formula, pull the area out of the denominator and just write it as 1 over a times the integral from c to d of y times f of y minus g of y. So it's the same formula basically as finding the x-coordinate when we were working with vertical rectangles, except now everything is in terms of y. If we were to find the x-coordinate, it's a little trickier because to define this distance, we have to use the average x value. So I'm going to write the sum of the first moments from c to d, and that distance here can be described as the average, which is f of y plus g of y divided by 2, then times the area of that rectangle, which can be described as f of y minus g of y, times dy. And this is again divided by the total area. So just like I did with vertical rectangles, we're going to take the 1/2 out and move it in front of the integral sign and simplify this. And we're going to bring the area out of the denominator and just combine it with the 1/2. So we're going to have 1/2 integral from c to d of, when we multiply these, we're going to get f of y squared minus g of y squared. It's like difference of squares, dy. So when I'm using horizontal rectangles, these are the formulas I use to find my x and y coordinates. Let's take a look at an example. Okay, in our example, it asks us to find the centroid of the area bounded by y equals square root of x, which looks like this, the y-axis, and y equals 2. This is the region we're working with, and we can do this using vertical or horizontal. It's actually going to be easier if we use horizontal, so let's do it that way and use the formulas we just described. Before I calculate the x or the y coordinate of the centroid, I need to calculate the area. Again, the area can be found using vertical or horizontal as well. If I'm going to use horizontal rectangles to calculate the centroids, I'm also going to use them to calculate the area. And all I have to do is write what x is equal to in terms of y. So if y is equal to square root of x, then x will equal y squared. So that's my function, my f of y, and g of y will be 0. So the area is going to be the integral from 0 to 2 of f of y, which is y squared, minus g of y, which is 0, dy. So that's going to be 1/3 y cubed, which will be 8/3. Let's start with the y coordinate of our centroid. So it will be 1 over a, so 1 over 8/3, times the integral from 0 to 2 of y times f of y is y squared minus 0 dy. So that will be 3/8 times the integral of y cubed dy, and that will be equal to 1/4 y to the 4th. So that can be written as 3/32 times 2 to the 4th power, which is 16. 16 cancels, so we get 3/2. So that's the y coordinate of the centroid. Let's calculate the x coordinate. Here's my formula for the x coordinate using horizontal rectangles. So it will be 1/2 times 8/3 times the integral from 0 to 2 of f of y squared, so y squared squared, minus g of y, which is 0, squared is still 0, dy. So that's 1/16/3, which will be 3/16 times the integral of y to the 4th dy, and that will be 3/16 times 1/5 y to the 5th. So I'm just going to leave that as 3/16 times 1/5, and 2 to the 5th, when I put the 2 in there, it's going to be 32. So the 16 will cancel. 3 times 2 is 6/5. Those are the coordinates for the centroid of that area. As a check, let's do this question again, but let's use vertical rectangles and make sure that we get the same coordinates. We already found the area, so I'm not going to calculate that again, but now I'm using vertical rectangles, so this is the formula I'll use for my x coordinate. When I'm using vertical rectangles, I have to have these values in terms of x. So when y is 2, x will equal 4. So I have to change to my x values rather than my y values. So I have 0 to 4 of x times the top curve, which is 2, minus the bottom curve, which is square root of x. So the length of this rectangle will be 2 minus root x dx. We'll simplify, so that will be 3/8. When I multiply, that will be 2x minus x times square root of x will be x to the 3/2 dx. And now we can integrate it. So that will be x squared minus 2/5 x to the 5/2, and we get 6/5, which we obtained using horizontal rectangles. And when we did it with horizontal, it was actually easier. But you can see that in this example, you can do it either way. Let's now use vertical rectangles to find the y coordinate. So I put the area in. We're going from 0 to 4. F of x, that's the top curve, so 2 squared minus g of x, which is square root of x squared dx. Let's simplify. 1/16/3 will be 3/16. Integral from 0 to 4 of 4 minus x, which is 4x minus 1/2 x squared. And now we evaluate it, and we get 3/2. So you can see we get the same result using horizontal or with vertical. Look at your question and just try to determine which is easiest and do it that way. Try to practice finding areas of centroids using either horizontal or vertical rectangles. And when you're ready, the next video is going to be on centroids of volumes. Take care and see you then.